All right, 7b, we were about to find VF. So VFX is going to just be VIX, which is 80 meters per second cos of 40, which works out to be 61.283 meters per second. And we can find VFY because we have VIY and AY and delta DY. So VFY squared is equal to VIY squared plus 2AY delta DY. So VFY squared is equal to VIY was 51.423 meters per second squared plus 2 times negative 9.81 meters per second squared times negative 50 meters. So when you square the 51 point, whatever that was, 4.23, you should get 2644.3258, etc. meters per second, meters squared per second squared. There's a decimal right in there. And negative is going to be positive, 100, this is going to be 981 meters squared per second squared. So when you add them together, you're going to get 3,625.325831 meters squared per second squared. And when you take the square root, you should get 60.2107 meters per second. Now, I did all of this out, hoping that this would remind you of something. Look over here. There's the 2,644, the VI squared. There's the 981. There's the 3,622, and here's your 60.21. So when you do the quadratic, what is actually under the root, what the discriminant it's called, is actually your VF, right? So this is your VF, there's your VI, there's divided by T, divided by A, and that gives you T, right? That's A equals VF minus VI over delta T. So the quadratic is really just putting this equation together with your A equals VF minus VI over delta T equation. So all of that to say, if you've already done the quadratic to get the time and then it asks you for the VF, I wouldn't make you do all this over again. You could just write down VFY equals the 60.2107 and then beside it write under root, so that I know you got it under the root and not off somebody else's paper. Okay, so in the end then, you have your VFX of 61.283 meters per second going this way, your VFY of 60.2107 meters per second going this way, and here is your VF. You're going to square them, add them together, take the square root, and get 85.91 or thereabouts meters per second. And this angle is going to be awfully close to 45, 44.49 WRT ground. Okay, number 7. Number 8. It's kind of cool. It's a cannon placed 1 meter from the edge of a cliff this time, okay? So here's my cliff. The cannon's back here, and it's shot, the ball's shot up at an angle, and it comes down, and as it comes down, it just clears the edge of the cliff, okay? And this distance here is 100 meters. And the height of the cliff is 150 meters. It just looks like it's less. And it tells us that it gets to this point at 4 seconds. And it wants to know the initial velocity. So the trick here is treat it as a ground-to-ground and ignore the second half in the beginning, right? So here's your VI, you have a VIX, you have a VIY, and you have the time so you can find it, right? In the X direction, you know, you don't know VIX, but you can get it because you know delta DX is 100 meters, and you know delta T is 4 seconds, and of course AX is 0. right? So you can get your VIX because it's just going to be delta dx is equal to VIX delta t plus the 1/2 AX delta t squared. This is going to go to 0. VIX is just going to be delta dx over delta t, or 100 meters over 4 seconds. So your VIX is 25 meters per second. Okay, now we look at the y direction. What do we know? Well, we don't know VIY, but we know the time up, delta TU, is 2 seconds, and we know AY is 9.81 meters per second squared down. And so this is just for the ground-to-ground piece. So you can do AY is equal to VFY minus VIY over delta T and look at just the up, so this goes to 0. So VIY is going to equal negative AY delta TU. So VIY is equal to negative 9.81 meters per second squared times 2 seconds. So VIY is equal to 19.62 meters per second. Once you have these, then you square them, add them together, take the square root, and you should get a VI of 31.78 maybe meters per second at an angle of 38.12 degrees WRT ground. Part 1, Part A, done. Part B says find the maximum height reached. Well, we can do that too, because we know delta D y max is equal to VIY delta TU plus 1/2 AY delta TU squared. So delta dy max is equal to 19.62 meters per second times 2 seconds plus 1/2 negative 9.81 meters per second squared, 2 seconds squared. Wait, I think we had these exact numbers. Y max is equal to 19.62 meters. Part B. Part C, total time in the air. So total time in the air means we now need this part where it comes down and hits the ground, which means you might need to do the quadratic again, but you can do that. Delta dy is equal to VIY delta t 1/2 AY delta t squared. It ends up 150 meters below. Our VIY was 19.62 meters per second. We don't know delta t. 1/2 negative 9.81 meters per second squared t squared. So 4.905 meters per second delta t squared minus 19.62 meters per second delta t minus 150 meters equals 0. Fill it into your quadratic. Negative 19.62 meters per second plus or minus square root 19.62 meters per second squared minus 4 times 4.905 meters per second squared times negative 150, sorry, lost my negative there, divided by 2 times 4.905 meters per second squared. When you do this, you should get a delta t of 7.88 seconds. Once you get that, it wants distance from the base of the cliff. So delta dx is equal to VIX delta t, 1/2 AX delta t squared. This goes to 0. Delta dx is equal to, it was what, 25. 25 meters per second times 7.88 seconds. You get a delta dx of 197 meters. But this is from where it's shot. And the question just wants the base of the cliff. So you have to subtract 100 meters. And you get a delta D from the base of the cliff out to be 97 meters. And we finished it in time. All right.